Hello, this is section 6.4 and we are going to be working with parameter t, and what that means is our functions cosine are going to be written in terms of t, also for sine. And we are going to learn how to rewrite two different equations in terms of sine and cosine in terms of just x and y. The steps we're going to be following are these three simple steps written down. We are first going to be given two equations, and with those equations, we are going to solve for the trig ratios. And that means we're just going to get sine and cosine by themselves on each side of the equal sign. Then we're going to substitute the results into the Pythagorean identity of sine squared plus cosine squared equals 1. And we are going to identify if we have a circle or an ellipse equation after that, and we are going to be graphing those. And hopefully this graphing is review for you because you should have done this last year in Algebra 2. So if we have a circle equation, that is when you are going to have two sets of parentheses squared equal to r squared. And remember, the center is at h and k, and the radius is just the square root of what it is set equal to. If we have an ellipse, the major axis is going to be our a value, which is going to be the greater denominator. If it is underneath the y, then our ellipse is going to be longer going up and down. If our a value, or if the greater denominator is under the x, then it is going to be opening and it's going to be longer going left to right. So that's just a quick review of our ellipses and circles. So we're going to start with a few examples. We are going to eliminate the parameter t for the parametric equations x equals 3 cosine t and y equals 2 cosine t, or 2 sine t, sorry about that. So our first step is we are going to solve these equations so that cosine and sine are by themselves. For our first one, that means we're going to divide both sides by 3. And we get x over 3 equals cosine of t. For our second one, that means we're going to divide by 2. And we end up with y over 2 equals sine of t. Then when we move on to step 2, we are going to substitute these into our Pythagorean identity of sine squared plus cosine squared equals 1. We know that sine is equal to y over 2, which will leave us with y over 2 squared, plus cosine is equal to x over 3 squared. And this is equal to 1. Once we simplify, we're going to have y squared over 2 plus x squared. Oh, this should be over 4. Sorry about that, because we have to square the top and the bottom. This one's going to be x squared over 9. Looking at these equations, this is going to give us an ellipse. There's nothing being added to the x or the y on the top, so that tells us that our center of our circle or our ellipse is going to be at 0, 0. So our third step, we are going to graph this. So to graph these, we are going to be taking them, and if we look at some examples, in this equation, you'll see that our major axis is just a, and we get that by taking the square root of the denominators. In this example, the largest value is 9. So if we take the square root of 9, that's going to be 3. So from our center, we are going to go 3 in both directions. to plot that point. Then if we do the same thing for our minor axis, take the square root of 4 is going to be 2. So we're going to go 2 going up and 2 going down. So the minimum number of points that you are going to need on your graph is 4. Oh, that deleted more than I wanted. So you should have each point on the major axis and then the minor axis. Then once you have that, you can draw your ellipse in the graph. So for this, your answer is 2 different parts. One part is the graph, and the second part is the equation that we have written down over here for the graph. So those are the 2 parts that you would need for your answer here. All right, let's go through another example. So we're going to start with step 1 again, and we need to write these equations in terms of sine and cosine. For our first one, we're just going to be subtracting 3 on both sides. And for our second one, we're going to be adding 2. Then we move on to step 2, and we are going to be substituting these values into our Pythagorean identity. So we're going to start with x minus 3 squared plus our cosine squared of y plus 2. And this is equal to 1. And if we look back at our equations, this is going to be a circle. We're not going to distribute these and multiply them out. We're just going to leave our equation like this. So for this circle, our radius is going to be equal to the square root of 1. And then we also need to find the center. If we look at our equation up here, our center is at HK. H we get from the x and K we get from the y. But because of these negative signs, we are going to be using the opposite signs when we graph them. So what that means is our H value here is going to be 3. Our K value is going to be negative 2 though. So that is where our center will be for our circle. We're going to go to 3, negative 2. Then we know our radius is 1, so we're just going to go and plot 4 points so we can draw a circle going through them. 1 going up, down, left, and right. And then that's our answer. And again, one part of our answer is the graph. The second part of our answer is the equation we use to draw the graph. Once you have that, you're good to go on to the next problem. So moving on to our next one, we're again going to eliminate the parameter t from the equation. So I would like you to try this one on your own. Once you have it, you can press play and then check your answer with the video. Alright, so for this one, our step 1, we need to get sine and cosine by themselves. That means we're going to divide by negative 1 for our first equation, which will give us negative x equals sine of t. Our second equation is already in terms of cosine, so we don't have to do anything for that one. Then we're going to go ahead and you should have substituted it into our Pythagorean identity. Once we've simplified, we would just have x squared plus y squared equals 1. This is going to be the equation of a circle, has a radius of 1, and the center of the circle is going to be at 0, 0, because nothing is being added or subtracted to the x and y coordinates. And when you graph your circle, it should have looked like this, with the center at the origin. All right. So if you need to fix anything on example 3, you can go ahead and do that. Once you are done with that, we can move on to example 4. Okay. So starting off with step 1, we're going to write these in terms of sine and cosine. For the first one, that means we're going to subtract 2 to start. And then we're going to divide by 3. And we'll go ahead and do that again on our second equation. We started by subtracting 1 and then dividing by 3 again. Okay, then we are going to move on to step 2. We are going to plug these into our Pythagorean identity. So we're going to start with our sine, which is x minus 2 all over 3 squared, plus, in parentheses, y minus 1 all over 3 squared. And this is equal to 1 using our Pythagorean identity again. Now, when you get a problem like this, we are going to separate the numerators and the denominators. So we are going to change this to x minus 2 on top squared, and then we're going to square the bottom. And when we do this, we are going to have an equation that looks like our ellipse again, where we're adding them and we have a square term on top and the bottom. Okay. So when we're doing this, we're going to look for the center of our ellipse. And again, this is going to be our HK. H goes with the X, K goes with the Y. So our H is going to be 2, K is going to be 1. So if we go and we graph our center, okay, and this one is unique because when we find our major axis, you'll notice that if we take the square root of 9, we're going to get 3, which is our first denominator, and our second denominator is also the same. So that means instead of an ellipse, we actually have a circle. And the reason that this is a circle equation is because we could go ahead and multiply every term by 9. And if we did that, we would end up with the equation x minus 2 squared plus y minus 1 squared equals 9. So if you think that you have an ellipse equation, but both of the denominators are the same, that means you actually are going to have a circle equation, which would mean that this would be our final answer. All right. So that is just 4 examples of these types of problems. If you have any more questions, please let me know. The homework is listed here, and it is on page 321. We are going to do numbers 3 through 11 odds. And if you have any questions, just let me know.